Pre-calculus. This is a recap of sections 2.2 and 2.3, hopefully to get us ready for the quiz that we have coming up. Okay, so we're going to consider this rational function right here, f of x. Okay, a couple things I might ask you to do with a function like this. Ask you if this point is on the graph. Okay, so the work that I would want to see, this is an x value and this is a y value. I'm going to plug them into that equation and see if it works. If it is a solution, then it is a point. Okay, so let's do, maybe I'll plug in f of 0. I'm going to plug in 0 and see what it makes. 0 minus 1 is -1. 0 plus 2 is 2. And that is not the output that they have stated. Okay, so is that point on the graph? The answer is no. Okay, so knowing x's are inputs and y's are outputs and knowing how to label what you're doing, make sure you tell me. I'm plugging in 0 into the f function. Okay, let's see. If I said if x is equal to 2, what is f of x? Okay, so what I'm going to do here is plug 2 into the function. F of 2. Okay, and that's how you properly label your work to tell me I'm now plugging in a 2. 2 minus 1 makes the numerator 1. 2 plus 2 makes the denominator 4. Okay, what is the point on the graph? I plugged in a 2 and I got the output of 1/4. That's the point. Input, output. Okay, let's just make sure we're doing proper labeling there. Okay, we had this a bunch on the homework the other day. People were asking me, what do I do with this? 3 is not the input. Okay, 3 is the output, and they want to know what is x. Okay, so I'm not going to plug 3 into the x spot. I'm going to put 3 into the f of x, the output spot. 3 equals equation. Okay. Now we did have this in our packet. I saw some people not have a lot of work here, so let's make sure we know how to show our algebra. I'm going to take 3 and I'm going to put a number down here. The number 1 is allowed. Okay, and how do you solve something like this? We're going to cross multiply. Cross multiplying is a great technique when you have a fraction equal a fraction. Okay, you can't do it when there's 3 fractions, just 2. So I'm going to cross this way. 3 times this entire denominator. That's going to be 3x plus, don't forget to multiply him, 6. Okay, and then you put an equal sign. You cross one way, doesn't matter, get the left side. Cross another way to make the other side. Stuff times 1 is x minus 1. If I minus x, that'll be 2x minus 6, -7. So it seems like x is -7/2. So when the input's -7/2, the output is 3. There was another question here. It said, what point is on the graph? I'm going to say -7/2, comma 3. That's the point on the graph. X value, y value. Okay. What are the x-intercepts? X-intercepts. We learned this last chapter. We're still practicing. To find an x-intercept algebraically, we're going to let the y value equal 0. So looking at this function, the y value is on the left. 0 equals x minus 1 over x plus 2. Once again, I'm going to put a number under 0, the number 1, which allows me to cross multiply. So here's my equal sign. Cross one way. 0 times stuff is 0. Expression times 1 is just that expression. Add the 1, x equals 1. Okay, but remember, an intercept is a point, so I'll state it as 1, 0. Okay, I could also ask you to find the y-intercept, and that's always the easier one. Okay, so be ready to show me some good algebra with functions. It could be a fraction, or it could be a polynomial, squared power, something like that. All right, something else that we studied was looking at graphs. Okay, so I'm going to look at this graph here. The first question is, what is the domain? Okay, so domain are the x values. I'm going to study the x-axis. I'm going to go as far left as I can. And just to exaggerate things sometimes, if it has an arrow, I just run it right off the graph paper. Right off the graph paper to make it obvious in my mind that the graph doesn't stop at -5 or 6 or 7 or -9 or -10. It actually keeps going. Okay, so the smallest x is -infinity. And then let's see, is there graph? Is there graph at -3, 2, 1? Yep. Is there graph at 1, 2, 3, 4? 5 has graph, 6 has graph, 7 has graph. In fact, there's no break in this graph at all. The graph is continuous from -infinity to +infinity. And another way of writing that, okay, I could write double bar R. Okay. When it says the range, okay, we're going to look at the y values. You're going to look up the y-axis. So you start the bottom of the y-axis way down here, and you see how far does it go. Does the graph touch -10? Yes. Does the graph go to -12? Yes. It goes down, down. So it starts at -infinity. Okay, and is there y values being used? Is there graph everywhere? There's lots of graph here. Yes, yes. The graph doesn't stop at 4, okay, because it keeps going all the way to +infinity. Okay, or you could say double bar R. So domain looks from left to right, and the range looks from bottom to the top, from small to big. Okay, to list the intercepts, okay, you're going to look at the x-axis, -4, 0. Remember, intercepts are points. And it says intercepts, all of them. So I'm either going to look on the y-axis and I'm going to say 0, 2. There's 2 intercepts. How often does the line y equal 2 intersect the graph? Okay, so let's go to y equals 2 is going to be a horizontal line. That's a hoy. So I go to 2, okay? And I'm even going to draw a horizontal line here to see how many times it intersects the graph. Okay, and the answer is 1, 2, 3 times. 3 times. If any of those were empty holes, then we would not include them. But we're going to say 3 times. Okay. I'm also going to ask you to take a look at a graph and be able to evaluate it a little bit. Okay, so for example, when it says f of 4, 4 is the input, okay, and they're asking for the output. This is the x value. So I'm going to go to 4, and I'm going to find the graph. And I see the point right there, and the point is 4, 1, 2, 3. So when 4 is the input, 3 is the output. That's the x value, that's the y value. That's the point. Okay, and if that was a hole, then I would just say no solution. Okay, should we put a little hint here for people? Okay, remember, that symbol means no solution. I didn't need it in this example, but just in case, just to remind you. Okay? All right, and now for the juicy one. It says for what values of x does f of x stay more than 0? Okay, so now we got to take a look at our graph. More than 0, okay, means you're only allowed to look up. Okay, so I'm even going to cover everything here. More than 0. You're not allowed to look down below the x-axis. You're only allowed to look up, okay, above 0. Now, since this says greater, okay, that means above the x-axis, okay, but it doesn't say equal to 0, okay. So actually, right here where we see this x-intercept, I'm going to change that to an open circle. And then I'm going to highlight this for you. Okay, here, this graph is all above, and this graph is all above, and all of this graph is above. Okay, what I like about this is it's continuous. Okay, and for what values of x? So it's like domain, but only this much domain. So I'm going to start right there at -4, and I'm going to put a parenthesis, and then all of the graph all the way forever to infinity. Okay? If I said greater than or equal, then you'd want to close that bubble and then use a bracket. Well, I know a good question. What if I ask on the quiz less than 0? Then you'd want to look at that little piece. That's the piece that's less than 0. Okay, so above and below 0, you look at the x-axis. Okay, something else that we asked you to do was operations with functions. Here's the f of x function. Here's the g of x function. And look what they want us to do. F divided by g. Okay, so I'm going to say f divided by g of x. Okay, and I don't know if I want to put this fraction on top of that fraction and make a quadruple decker fraction. Do you remember what we said to do? Yeah, okay, let's go old school. Let's not put a big divider. Let's use the old school divide sign. F gets divided by g. Okay, and then what we're going to do is we're going to take this right here, and we're going to change divide into multiply. And don't forget to reciprocate your second function. So it's going to be 9 over 5x. Now what you do when you multiply fractions is you just multiply top with top and bottom with bottom. But here I'm going to cancel first. Okay, this is just a constant and a constant. This is legal. You can cancel. Should I chop this x and this x? Well, no, for lots of reasons. This is a whole quantity, okay, and that's a radical x and this is a plain x. Okay, so parentheses and quantities stay together, all or nothing. I'm going to move that 3 to the front of the radical sign so it doesn't get lost. Nice big radical sign, please. All over 5x. Okay, so that's the function, f divided by g. And now let's talk about domain. Okay, where do we look for domain? Should I look at the beginning, or the middle, or the end? And the answer is you look everywhere. Sometimes it helps when I'm doing the problems to calculate their domains individually. Okay, so for right here for f, I notice an expression under the radical. So let's see, 2x minus 4 has to be greater than or equal to 0. Greater than or equal to 4. X has to be more than or equal to a 2. Okay, so this is the domain for f of x. Here's his domain. Let's talk about g of x. G of x does not have any x's in the denominator. He does not have any radicals, so he will accept all reals. Okay. Now let's also look at the problem. Okay, I already took care of this radical. Oh, right here. Okay, when I reciprocated and I put 5x into the denominator, that's going to add on a restriction. 5x cannot equal 0. So now x cannot equal 0. Now I have to figure out who I'm going to listen to. I'm not going to listen to g of x. Okay, I know he will allow everyone, but these other guys have a problem. Okay, so am I going to use all reals? Certainly not g. Sorry, can't listen to you. F says take numbers that are 2 or more, okay, and I'll work with all these numbers 2, 3, 4, 5. And then this restriction says don't use 0, but since 0 is way over here, okay, I'm not planning on using him anyway. So let's combine all these answers to make an overall domain of numbers that start at 2 and greater than 2. Okay, so you can state your answer like this, or you could state your answer bracket 2 to infinity. Okay, let's just be clear. If the directions state, make sure your answer is in inequality notation. Inequality means the greater than less than signs. And if it says use interval notation means use the parentheses and brackets. So here's the two kinds of notation that we've learned so far. Okay, so that's a recap of everything we're supposed to know so far. Okay, let's keep going with just a little bit more to kind of get you ready for the next part of this chapter. Now we're going to talk about composing functions. Okay, people that compose in English class, they put a bunch of sentences together, and people compose musical notes. They make a composition. Okay, so lots of different classes do composing. But to compose a function, it means that you're going to put a function into another function. Okay, what? We're going to put two functions together. Okay, I'm going to try to make this nice and easy for you. Okay, so here's a little bite of food. I'm going to call that food X. Okay, now there's going to be this fish that comes along. Okay, opens his mouth. Okay, here's my beautiful fish. Okay, give him a little tail and an eyeball. Okay, and maybe some teeth. Make him really hungry. Give him some teeth, okay? This fish is called G. And G is going to gobble up the X food. So X goes into G. But, okay, here comes a big hungry shark. Big hungry shark. Big one. Draw a big fish. Okay, some big sharp teeth. Okay, and what function is this? Give me an eyeball. This is the F function. Okay, so F is eating G, who's eating X. We're not going to do eating, but that's what's happening. Okay, we're putting something into something which goes into something else. Here's the notation for that. Okay, F of G of X. Right here, I want you to take note of that open bubble, okay, and say the words of. It's not times. This is not F times G. No, this is of. This is gobbling him up. I'm going to color code this for you. So the first big shark, the big one is F. Okay, F of. And then what did F eat? F ate this green little fish here, G. And G was of the variable X. So when you compose functions, okay, they're all going to have the same letter. It's G of X going into F of X. I know, it's kind of weird. We're going to just start off with some numbers. Okay, so the first thing I want you guys to do is to take a problem like this, and let's write it where it doesn't look like the word fog. Let's take F, okay, F of, and then what does this say right here? It says G of 1. Okay, nothing here says multiply. So what I need to do is plug 1, the number 1, into the G function. And then that answer has to go into the F function. But we have to make sure we write it correctly. Okay, so equal sign, please. F of. All right, I'm going to work inside out. So the 1 is going to get things started. It's going to go into G. So let's take G. Can you guys plug 1 in and tell me what the answer is? Good. Okay, it's a 4. Now, we're not done. Okay, see how it says F of 4? Now this answer has to go into F. So let's go to F and let's calculate 2 times 4 squared minus 3. Okay, and the answer is 29. Good. Okay, so let's go ahead and write this. I did F of G of 1. And this is exactly how I want you to label your work. Tell me what function, what into what function, and it started with what number. All right, let's try another one. Okay, this says G of F. So we're going to take that first letter and say G of. Okay, let's write it with the nice notation. And then we've got F of 1. Okay, so we're going to plug 1 in. Okay, but the little function here is F. So you need to write G of, because G hasn't happened yet. I'm going to calculate the inside first. 1 needs to go into F. Okay, so let's take F, put 1 in, square it, times by 2, minus 3. What do you get? -1. Okay, but you're not done, because now that needs to go into G. So where's G? G says 4 times input. So we get -4. Okay, and let's label our answer here. This is the calculation. G of f of 1. So does it really matter if you do f of g or g of f? Does it really matter? Yes, totally matters. The answers come out different because an answer is going into a function. Okay, look at this. Is it possible to do f of f, f of -2? Can you do the same function into itself? Sure. Okay, we're going to put f. We're going to start with -2. We're going to plug that into the f function. So go to the f function right here. -2, square it. Positive 4 times 2. 8 minus 3. Okay, we're getting a 5, right? But now we don't stop. Now you take that answer. Let's go back to the f function. Okay, square it. Times by 2. Minus 3. 47. Good. Okay. f of -2. We didn't use g at all. Okay. So this is how you plug numbers into functions and then into other functions. Okay. Okay. And the number that we're plugging in is that little bite of food who gets gobbled up by g, and then the whole thing gets gobbled up by f. Okay. You could do the same thing with a table. So here's the x's. That's going to be the row of inputs. Here's the f of x, and then here's the g of x. So if you had 0, 0 into the f function is -1, but 0 into the g function, oh, it's also -1. Bad example, I should have picked one of these. Okay, so the first thing we're going to start off with our notation, and we're going to say f of, and then this says g of 1. Okay, so it's a two-stepper. Let's make sure we use some good notation here. F of. Okay, first you do the inside. So your input is 1. So go to the top column here for x and find 1. And we're going to plug that value into g. Plugging it into g gives us a value of 0. Value of 0. Okay, so that goes right there. Now you're not done. Okay, now 0 becomes the input. That's the input, so you have to go back to the top of the chart. 0 is the input, and it's going into the f function, which makes an output of -1. Let's try again. Let's do another one here. I'm going to write this as the nice notation. This problem wants us to do f of g of -2. Okay, so the first thing I'm going to do is I'm going to write equal sign. F of. Okay, so I'm going to save f. I'm going to work from the inside out. I'm going to put -2 into the g function. So -2 is the input. When it goes into g, the answer is 3. Okay, so that goes right here. So this is the first answer I need to see. I need to see your first step so I can know that your second step came out right. Now, I'm not going to write f because I'm going to calculate f. See how every line you lose a letter? Okay, because you're doing the function. 3 is the input, and it goes into the f function for an answer of 5. Okay, are you starting to get the hang of it? We're just doing numbers today. Tomorrow we'll start to do letters and stuff. We got g of f of -1. Okay, so can you take this of notation and show me the nested form? Okay, step 1, write your outside letter, and let's calculate the inside. If -1 is the input, and it goes into the f function, we get -3. Okay, now we're not done, so we still have to do the g of -3. But as I do g of -3, I don't write the letter anymore. I'm just going to write the output. So -3 going into g makes 8. 8. Okay. All right, we got a double one here. We've got g of -2. Can we do g twice? Sure. Okay. So the first step, plug -2 into g. -2 into g, and we get a 3. Now we have to do g of 3. So go back to the top of the chart and find input 3. And the g output of 3 is 8. Okay, one more way of doing this. Okay, I could give you a graph. So we could have some graphs drawn for you. So the f of x function is right here. Let's just highlight these. Okay, so here's the f function. It's this one right here. And we also have the g function, which is right there. Okay, so for example, there's this point right here. On the f function, that's 2, -2. So that's 2 for the x value. Going into f, you get -2 as the y value. All right, let's try some of these here. We've got g of f of -1. Okay, so we're going to write the g letter. And the first thing I need to do is go to the f function, okay, which is down here. It's this v graph. And you need to find -1 as the x value. -1. Oh, here it is. Okay, so here's the point I'm looking at. -1 is the input. What's the output? You just look at the y value, 1. Okay, but we're not done because now I have to take 1 and now I have to look at the g graph. So I'm looking at this curvy graph here and 1 is the input. When I say input, I mean x value. So I'm looking, oh, here's the point right here. 1 is the x value, the input, and the output is 4. So we're looking at graphs and we're looking at x and y values. Okay? Some people get this real fast and some people need a couple of examples. So if it's making sense, great. Okay, you got it. G of f of 0. Okay? Some of us just need to work on notation and being clear about what we're doing. Even though you can quickly get the answer, we got to explain our thoughts a little bit. G of. So let's go to the f function, which is the v. And we're going to go to 0. 0. Oh, it's right here. Okay? I can draw my own little point. That's the origin. If it helps for you to write the point 0, 0, then go ahead and write the point. When 0 is the input, 0 is the output. Okay? But we're not done because now 0 becomes the input for the g function. So go to the curvy g graph and we're looking for an input of 0 so we can find the output. Okay. Now I don't see it on here, but it's right here. Okay. If putting a dot makes you feel better, you can put the point. In fact, putting the coordinates 0, 5 might be helpful. So 0 is the input and 5 is the output. Okay. All right, let's do letter C. We've got f of g of -1. Okay, so we're going to start in the inside. We're going to go to the g graph. Oh, we're going to start the g graph. Okay, so let's go to the curvy graph. -1 is the input. What output does he give us? Here's the point. And the output is 3. But we're not done. Okay, now we're going to go to the f graph, which is down here. 3 is the input, and we have to find the output. Oh, when I say input, I mean x value. 1, 2, 3. Well, where is it? Oh, I think it's right here. Right there. Symmetric to that point. Let's go ahead and write the coordinates for people. 3, -1. Okay, so the y value is -1. All right, I need you guys to give D a try. So tomorrow in class, I can check to make sure you watch this and you tried and you understand, okay? Can you use 2 different notations for composing? The O, the of, and then the nested form. Okay, yes, we practiced that. I can evaluate by composing functions using tables or equations or graphs. Can you put a number into a function and then into another function? Okay. Thanks, everybody.